rainfall, the record for highest rainfall in an hour is 164.6 mm that have been recorded in Perai, Penang on 14 August 2017. And this event actually occur due to the tail effect of the Typhoon Lekima that heading toward eastern China at that time, and cause continuous heavy rain and thunderstorm over the northwest region of Peninsular Malaysia. And other record for highest rainfall in a day is 600.8.1 mm that have been recorded in Kota Baru, Kelantan on 6 January 1967. This event was actually occurred during the northeast monsoon season. Next, before we go through our topic on distribution of rainfall, I would also like to share the rainfall monitoring network of the MMD Meteorological Station. In general, we have 43 principal stations with 384 auxiliary stations all around Malaysia, including Sabah and Sarawak. And this is the location of the principal station. The principal station operate more extensive observation program compared to the auxiliary station. And this station basically observe and record surface weather parameters such as the weather, rainfall, wind, cloud, visibility, humidity, temperature, pressure, and also sunshine and solar radiation. This is the location of the auxiliary station. The auxiliary station comprised of three types of station, which are the AWS station, the rainfall station, and also the climatological station. And compare to the principal station, the auxiliary station operate less observation program, which include only the basic element such as the rainfall, wind, humidity, temperature, pressure, and also sunshine and solar radiation. And now we go to our topic, which is the distribution of rainfall in Malaysia. Let's start with the cluster of rainfall. The main purpose of rainfall clustering is actually to provide an overview of the spatial rainfall pattern in a region. And generally, in Peninsular Malaysia, we have 4 clusters of rainfall, which is over the northwest, west, northeast, and east. And this cluster actually based on the climatological zone, where the difference in amount of rainfall are based on during the season contribute to the different type of cluster. In other words, we can say that the different type of cluster are influenced by the main monsoon season in Malaysia, which is in the northeast monsoon and and the northeast monsoon and also southwest monsoon. And also, in addition to this, the geography factor and the location of the station also influence the cluster. Next, we look at the mean monthly rainfall from the MMD principal station. In general, we can see Perlis, Kedah, and Pulau Pinang actually is located over the northwest region of Peninsular Malaysia. And as we can see, in average, there are 2 peaks of maximum rainfall, which is during the inter-monsoon. And as you can see here, there is a slight increase in rainfall during the second period of the inter-monsoon over this region. This is actually due to the convergence of northwesterly wind and southwesterly wind, which produce extensive moisture over the region during this period. And now we look at the mean monthly rainfall in Perak and Selangor. which is located or include in the western region of the west coast of Peninsular Malaysia. As we can see, there are also two peak maximum rainfall, which is during both period of the northeast monsoon, and compared to the rainfall in the northwest region, the rainfall in this area actually show fairly the same. Fairly the same amount. Okay, these two intermonsoon season show fairly the same amount with these two period as compared to the northwest region. In the slide, last slide, that show the second period of intermonsoon show a little bit higher rainfall. And we look at the mean monthly rainfall in Negeri Sembilan and Melaka, and in this area also for Negeri Sembilan, we can see it is show two period of a maximum rainfall during the intermonsoon, and a slight difference we can see in Melaka, where the uniform rainfall occur from April to November. This is actually due to intermonsoon period, and also the impact of the squall line during southwest monsoon from May to September. Due to the location of Melaka Station is located near the coastal area, and when the squall line pass through, and it can through the station here. And now we look at the mean monthly rainfall in Johor. As we can see here, for Johor in general, there are two different pattern of rainfall between the west region and also to the eastern region. Where the western and central region show maximum rainfall during the intermonsoon. Meanwhile, over the eastern region show maximum rainfall during the northeast monsoon, which is from December to January. And as we can see for Pahang also, we show two different pattern of rainfall, which is in central and western Pahang show maximum rainfall during the intermonsoon, while for the eastern region show maximum rainfall during the northeast monsoon. And for the info, actually the amount of rainfall in Pahang during the northeast monsoon actually contribute to the 60% of annual rainfall in this region. So now we look at the mean monthly rainfall for Kelantan and Terengganu. As we can see here, there is a very significant increase of rainfall during northeast monsoon in these two states. And as for Pahang, the rainfall in Kelantan and Terengganu during northeast monsoon season also contribute to the 60% of their annual rainfall. And now we look at the mean monthly rainfall in Sabah, where for Sabah in general, we have three pattern of rainfall, which is over the eastern region, we can see that the maximum rainfall occur during the northeast monsoon. This is actually due to the easterly wind penetration during the northeast monsoon, and also on the over the western region, we can see the rainfall is uniform and maximum during May to November. This is actually due to the impact of squall line, and also the development of a tropical cyclone over the western North Pacific that will impact western Sabah during this period. And also, as we can see, the interior area and also the southern area of Sabah, as recorded, there is only slight or less rain as compared to the other region in Sabah. Now let's look at the mean monthly rainfall in Sarawak. As we can see, in general, actually Sarawak record significant increase during the northeast monsoon, which is from December to January, especially over the western region of Sarawak. This is actually due to the formation of the Borneo vortex associated with the cold surge and the low pressure system or cyclonic vortex over the South Chinese Sea during this period. And now we look at another pattern of rainfall, which is the diurnal rainfall. As Malaysia is surrounded by ocean, the rainfall pattern in Malaysia is highly influenced by the effect of the land breeze and also sea breeze. And moisture transport by land breeze and sea breeze are proved to be the main factor that structure the diurnal rainfall in Malaysia. And in general, we have four main diurnal rainfall, which is during the intermonsoon, northeast monsoon, and also during the southwest monsoon. And let me show a few diagrams to see this pattern. Okay, this is the diurnal rainfall pattern during the intermonsoon, where during this season, as we can see, in the afternoon at 14 local time, the sea breeze becomes dominant, and the surface wind are strong at a high level, and the moisture and vertical wind shear also increase. Then this condition will produce stronger convection of the west coast of Peninsular Malaysia. And due to the strong sea breeze during in the afternoon, the convection cloud are forced toward the inland area and over so we will have heavy and frequent rainfall at the foothill of Titiwangsa mountain range in the afternoon. And okay, now we look at the diurnal rainfall pattern during northeast monsoon. As we can see, during northeast monsoon, strong monsoon surge is barred by the land breeze and reduce the area of the orographic barrier. And the rainfall mainly at this time only concentrate over the east coast of Peninsular Malaysia from morning until afternoon. And so we will have the heavy rain throughout the entire day. However, in the afternoon, the strong sea breeze that enhanced by the surge expand the orographic barrier into the inland valley. The convection that only occur over the east coast of Peninsular Malaysia in the morning now will extend into the inland valley in the afternoon. So we will have another pattern of rainfall, which is the heavy and frequent rainfall over the inland valley area in the afternoon. Now we look at the diurnal rainfall pattern during the southwest monsoon. As we can see here, in early morning between 02 local time, the strong land breeze in the west coast of Peninsular Malaysia and also the strong land breeze over the Sumatra terrain will produce squall line over the Strait of Malacca. And when the sun rise at around 8 local time, the land breeze weaken and the strong southwesterly wind will propagate the squall line from the Strait of Malacca toward the west coast of Peninsular Malaysia. So we will have the extreme morning rainfall due to the squall line, but in low in frequency over the west coast of Peninsular Malaysia.
And sorry, Ms. Fadila, I interrupt you. We have another 1 minute.
1 minute. Okay.
Yes.
Okay. I'll show another pattern of rainfall, which is during the monsoon surge. Generally, monsoon surge is a significant feature that contribute to the heavy rainfall during the next monsoon, and I will show the effect of or influence of the monsoon surge that will influence or develop a heavy rainfall over this particular area in November, and in December. This is a pattern of rainfall that influenced by the monsoon surge, and this is on January, where the maximum rainfall will occur influenced by the monsoon surge. And this is actually I want to share about the influence of ENSO on the distribution of rainfall in Malaysia. As we can see, weather in Malaysia are generally dry during El Nino and wet during La Nina, and depend on the season and location. Dry precipitation extreme are tended to be enhanced during El Nino, while the precipitation extreme are tended to be enhanced during La Nina. However, this is actually depends on the intensity of ENSO. Let's see the diagram and explanation. And generally, the different intensity for El Nino, which is between weak, moderate, and strong El Nino, show similar impact on the precipitation extreme. However, La Nina show different impact between different intensity, where the strong La Nina reduce the precipitation extreme, while the moderate La Nina enhance the precipitation extreme. This is due to the condition of SST and also the availability of moisture. So we can say that in general, the heavy rainfall episode over the east coast of Peninsular Malaysia will increase during a moderate La Nina, but not during strong La Nina. And this is the conclusion, a little bit on conclusion, where I just want to highlight that basically the rainfall distribution that I share in the slide is based on the climatological data, and it also can be used as the one of the general info and to predict the weather and also to predict the climate in Malaysia. However, the use of numerical weather prediction, NWP, and also the climate model are most effective actually to make a good forecast, as this method use an atmospheric and oceanic model based on the current condition to predict the weather. And at the very end of my presentation, I would like also to share a few products that we use in MMD to forecast the weather in 3 different time scale. And this is I want to show you about. This is our product. Radar integrated navigation system, or we call it RAINS, that we use to nowcast and to observe the current weather and forecast up to 3 hours ahead. And this is our numerical model that we use to forecast up to 7 days. And this product actually able to produce high resolution forecast up to 1 kilometer scale. And this is the product that we use in to forecast from 1 month to a 6-month period. This product actually based on the selected climate model and the consensus of meteorologists in MMD. And I think that's all I would like to share today. Thank you.
Thank you, Ms. FADILA JASMIN, for the sharing session about the distribution of rainfall in Malaysia. I open, if anyone, one question, please.
Can I ask a question, please?
Sure.
Sure.
Okay, Ms. Fadila. JPS, DID, Department of Irrigation, also has their own stations.
Yeah.
Do you, take into account their data also for your modeling purposes?
For the modeling, we actually use our own model, but we also we have several or a few collaboration with the JPS to produce to use and share our rainfall data and at this moment, the rainfall data from JPS we use in our certain project, and not assimilate in our numerical model, because we only use our own model. For the rainfall data from JPS, we use in collaboration and in different. We have project lah with them.
Well, I was thinking that if you take into account their data, also your modeling would be much accurate. I would think so. Right. Anyway, thank you.
Yeah. Thank you. Thank you.
Thank you, Prof. Tamizi, for your participation in this session. All right, thank you, Ms. Fadila Jasmin FAKARUDDIN from Malaysia Meteorological Department, for
You're
your
welcome.
very well information on your speech. And perhaps those participants who want to interact or communicate with her, you can contact her directly. Yeah, probably Ms. Fadila can also share your contact number in this Zoom meeting. All right.
Okay.
On
Thank
behalf
you.
of the committee, I would like to thanks again for your time and for your valuable contribution to this seminar. Thank you.